So students, welcome back to my lectures of class 10 physics. We are studying our chapter I and the colorful world. In this video, we will talk about the topic that is scattering of light. First of all, what this scattering means? This scattering means बिखरना, मतलब light का बिखरना in various different direction, that is called as the scattering of light. So to throw the light in various random direction means that whenever we have a particle, and when light strikes to that particle, then that light that scatters in the random various different direction, that phenomena is called as the scattering of light. Now here, don't get confused in dispersion and the scattering of light. Okay, in case of dispersion, we have a medium through which light splits into 7 parts, and here we have a particle through which light moves randomly in the different directions. Okay, so here the phenomena of change in the direction of प्रोपोगेशन ऑफ लाइट, मतलब जो लाइट मूव कर रही है उसका डायरेक्शन चेंज करना बाय लार्ज नंबर ऑफ पार्टिकल्स प्रेजेंट इन द एटमॉस्फेयर. किसकी वजह से? जो पार्टिकल्स हमारे पास एयर में प्रेजेंट है. बिकॉज ऑफ दैट वी हैव द फिनोमिना स्कैटरिंग ऑफ लाइट. एंड व्हाट दिस फिनोमिना डज, यहाँ पर क्या होता है कि दिस स्कैटरिंग मेक्स द पाथ ऑफ लाइट विजिबल. अगर कहीं पर लाइट की स्कैटरिंग हो रही है तो वहां पर आप लाइट को देख सकते हो. If there is no scattering, it means you won't be able to see light. Light को हम देख नहीं सकते. But you might have seen that in a dense forest, कहीं से एक लाइट आपको नजर आती हुई दिखती है. That is called as the scattering of light. और अगर आपको वहां पर लाइट दिख रही है, इसका मतलब वहां पर स्कैटरिंग हो रही है. And that phenomena is called as the Tyndall Effect. That is because of the scattering of light that we will see. Here, suppose if we have the incident light and we have a particle. This particle is also called as the scatterer, जिसकी वजह से लाइट scattered होती है. And here we have the different direction in which the light gets scattered. Okay, so this is what the scattering of light is. Now here we have another phenomena that is related with the scattering of light, that is the Tyndall effect. So the phenomena of scattering of light by the colloidal particles is known as Tyndall effect. अगर हमारे पास एक solution है या फिर हमारे पास जो एक सिस्टम बनता है, अगर वो कोलोइडल है, इन दैट केस वॉट एवर द स्कैटरिंग इज टेकिंग प्लेस, दैट इज कॉल्ड एज द टिंडल इफेक्ट. अब यहाँ पर आपने केमिस्ट्री के अंदर पढ़ा होगा ट्रू सॉल्यूशन एंड द कोलोइडल सॉल्यूशन. व्हाट ट्रू सॉल्यूशन इज? ट्रू सॉल्यूशन लाइक वी हैव द सॉल्ट इन वाटर that completely dissolves in it, that's a true solution. But if we have the particles which are suspended in a liquid, then that comes under colloidal solution. Okay, so you have the difference of this true solution and the colloidal solution based on the size of the particles. तो हमारे पास कुछ एक regular size के particles होंगे in the air, then whatever the scattering we will get, that is called as the Tyndall effect. Okay, so when a beam of sunlight enters a dusty room through window, अगर हमारे पास कोई एक रूम है उसके अंदर 10 particles हैं and we have a hole or a window through which the light is coming, then its path becomes visible to us. This is because the tiny dust particles present in the air of the room scatters the beam of light all around the room. This, you might have observed this, that from a window in a closed room, the light enters. Then you might see the dust particles in that path of light. और वहां पर आप कह सकते हो कि बिकॉज ऑफ दैट स्कैटरिंग ऑफ लाइट दैट पाथ ऑफ लाइट इज विजिबल टू अस. और वहां पर वो जो पार्टिकल की साइज होती है उसकी वजह से हम वहां पर कह सकते हैं दैट्स अ काइंड ऑफ कोलोइडल सॉल्यूशन. और वहां से जो स्कैटरिंग होती है दैट इज कॉल्ड एज द टिंडल इफेक्ट. Okay, so the Tyndall effect is also observed when the sunlight passes through the canopy of a dense forest. जब भी आप कोई भी डेंस फॉरेस्ट को ऑब्जर्व करते हो तो वहां पर भी आपको स्कैटरिंग दिखती है, वहां से एक लाइट आपको बाहर आते हुए नजर आती है. अगर हम डस्टी रूम की बात करें तो वहां पर आपके पास 10 पार्टिकल्स होंगे. बट व्हेन यू टॉक अबाउट द फॉरेस्ट, देन द वाटर ड्रॉपलेट्स इन दैट डेंस फॉरेस्ट, दे आर रिस्पॉन्सिबल फॉर द टिंडल इफेक्ट. So this Tyndall effect, that is because of the scattering of light due to the colloidal solution. Now we will see how we can experimentally demonstrate this Tyndall effect. Now here we will see the experimental demonstration of Tyndall effect, that how the light path is visible to us when the light passes through a colloidal solution. Okay, here we have the arrangement of the experimental demonstration. Here we have a source of light. Now what this source will do, this source will give out the light in different direction. Okay, but we want the parallel light which should pass through the solution. तो उसके लिए हमने क्या कर रखा? We have used a lens L1, that is the convex lens. इसकी वजह से क्या होगा? Whatever the light will pass through this lens, all the light rays will become parallel to it. Okay, or we can say this source is kept at the principal focus of this lens. तो जब भी हमारे पास कोई सोर्स या लाइट सोर्स या ऑब्जेक्ट अगर प्रिंसिपल फोकस पे होगा, then the light rays will be parallel to the principal axis after refraction that we have seen in the previous chapter. Okay, so here all these lights will be parallel to each other. Now here we have the tank. Okay, in this tank this light will pass through it, and after that this light will move outwards from this tank. Okay, now here we have a cardboard C. In that cardboard we have a small hole. Okay, now here this light will stop from this cardboard, but through the holes this light will pass. So we can say this light passes through this hole, and these lights will be parallel to each other. Now here we have the another lens L2. अब हम क्या करते हैं कि यहाँ से अगर लाइट रेज एक लेंस के ऊपर पैरेलली फॉल कर रही है, देन आफ्टर रिफ्रैक्शन दे ऑल विल मीट एट अ पॉइंट एंड दैट विल बी इट्स प्रिंसिपल focus. Okay, so here we have again a cardboard, and on that cardboard these light rays will meet and we will get the image of this hole on this screen. Okay, so this is what the arrangement we have. Now here in starting we have the water in this tank, और अगर जब यहाँ पर water होगा and then when we will allow the light to fall through this container, in that case this light will directly pass through this and we will not be able to see the path of light. Why? Because the solution which we will have here, that will be true solution, और true solution के अंदर हम scattering phenomena observe नहीं कर पाते. Okay, so now in order to make this solution as colloidal solution, we will use a chemical that is sodium thiosulfate. So what we will do, we will take sodium thiosulfate up to 200 grams and we will mix it in this water. Okay, now after mixing it, we will take 1 or 2 drops of sulfuric acid. Okay, and then we will mix this solution, and then when we will repeat this same experiment, then what you will observe? You will observe that the path of light will be visible to us. And why this path of light is visible to us? Because of the scattering of light which we are getting from the colloidal solution which we have obtained from this sodium thiosulfate. Okay, and we will see this path of light through this container and we will get the image on the screen. Okay, now one more thing, if we will wait for 1 to 2 minutes, 1-2 मिनट के बाद क्या होगा, we will get the precipitation of this sulfur. जो सल्फर होगा वो यहाँ पर क्या हो जाएगा, प्रेसिपिटेट हो जाएगा. And after that what we will observe, when you will see this container from this side and from that other side, it means from the 3 sides you will see the color of the container to be blue. Okay, and when you will see from the 3rd side, then you will see a crimson red color. Okay, वहां पर आपको red color या फिर orange color type में आपको वहां पर color दिखेगा from the 4th side. Now why this is so? This is because again due to the scattering of light. Here we have a relation with the scattering of light and the wavelength. Wavelength and scattering, they both are inversely proportional. Now how this is, we will see it in the next video when we will see the different phenomena related with the scattering of light. So this is the experimental demonstration of Tyndall effect, and this is all about the scattering of light.